So today, so far we have taken the slope deflection method applied for continuous beams, having supports at same level in the beginning. Later on, we took the yielding of supports in the form of rotation as well as settlements. So today we will start with the rigid jointed frames. We call them as portal frames. There is a two part in that. One is called as non-sway analysis, another is a sway analysis. Let me start with the first. What is a portal frame? So portal frame can be defined as a two-dimensional rigid frames that have the basic characteristics of a rigid joint between the column and the beam. The main objective of this form of design is to reduce the bending moment in the beam, which allows the frame to act as one structural unit. Means if you look at this, this is a structure. It is called as a portal frame. It is two columns are supporting here beam, and the joint between the beam and the column we take it as here rigid. The column and joint between the beam and the column we take it as rigid. Here the horizontal member is called as beam, whereas vertical members are called as columns. Now this beam has got two joints, with one with this column, another is with this column, and those joints we are considering them as rigid. Even in continuous beam, all joints are considered as rigid. The main objective of this form of design is to reduce the bending moment in the beam, which allows the frame to act as a one unit. Now this beam and column will not act as a separate, they will totally act as one unit, and this is called as a frame. Okay. Now here in the first non-sway analysis, we are considering only symmetric frames. For example, say now base conditions, both ends fixed, it is carrying point load at the center. So second, say now it carries 2 point loads and placed at equidistance from the either end. This also is a symmetric frame. Or a frame with UDL throughout the span, that beam is carrying the UDL. So this is also symmetric frame, right? So these are all symmetric frames in terms of end conditions as well as in terms of loading. And here there is no sway. Sway means here lateral moment of the frame. If the frame moves towards either left or right, or if it settles one of the support, then we call it as that sway or a translation or lateral moment. So there will be no translation of the joints or lateral moment of the joints. That is why we call them as a non-sway analysis. Okay. Next, let us consider what is sway analysis then. Sway means the translation, that is movement of joints. The movement or translation may be either horizontal or vertical. So if you look at this problem, this is an unsymmetric frame because the columns are of a different height. If the columns are of same height, then it will become a symmetric. If the columns are of different height, then it is called as a unsymmetric. In that case, it moves towards the right side. By how much amount? Say it is delta. This delta is called as a translation, or it is also called as a swing. Both columns will move by same amount, that is a delta. This movement is a horizontal movement. Okay. Next case, suppose if the columns are of same height, suppose in any of the one column support settles down, then automatically the deflected shape will be, I have shown here with blue line. So here with blue line, it is a lateral moment or horizontal moment. Here it is because of the settlement of the support. Again here the vertical moment of the beam, this beam will take place this much, right? And here also the lateral moment of the column. So this is what we call it as a sway analysis. Means if the lateral moment is there, that the analysis of the frames having lateral moment, we call it as sway analysis. The analysis of the frames which are symmetric in nature, where there is no sway, we call them as a non-sway analysis. Okay. Now, in this case, that means the frames which are having sway, in this case, translation become additional unknowns. Basically, the joint rotations are the unknowns. In addition to that, now this translation, this delta will become the additional unknown. Okay. Then, so to solve these continuous beams, already you have used, that is joint rotations. To calculate joint rotations, you have used the joint equilibrium conditions. Now here, along with this theta B and theta C, suppose if this is A, B, C, D, along with theta B, theta C, now delta is the another unknown. For finding theta B, you use two joints, that is MBA plus MBC equals to 0 for joint B, and MCB plus MCD for joint C, that is equals to 0. So you are finding two unknowns. But now, as there is a third unknown along with theta B and theta C, there is a delta. So we need to have one more joint equilibrium condition. Then what is that condition? The additional condition of equilibrium now we need to apply, that is from the consideration of shear force exerted on the structure by the external loading. That means we call that as a shear equation. So what is the shear equation? Means you have to write down sigma fx equals 0 for the whole frame. Total frame including both columns and beam, it is a whole frame. For that you have to apply sigma fx equals to 0. That is what we call it as a shear force. Here for the frame, shear force means lateral moment, lateral force, which causes the shear. So that total, if you write sigma fx equals 0 for the whole frame, and this equation we call it as a shear equation. In addition to those two joint equilibrium condition, you need to write now another condition that is called as a shear equation, or this is also called as the equilibrium equation, which is nothing but sigma fx equals 0 for the whole frame. Okay, so is this clear now? The idea of this sway and non-sway. In sway analysis, there is a lateral moment along with joint rotations. So along with joint equilibrium conditions, you are using one more equilibrium equation, that is called a shear equation, that is nothing but sigma fx equals 0 for the whole frame. Whereas for the non-sway analysis, you have symmetric frames, and there will be no delta, that is a sway or a translation. You will be having only joint rotations, and that can be done as usual by what you applied the method for the continuous beam. Same method can be applied for these frames. So shall I proceed? Is this clear now? What is sway and what is non-sway? Hello?
Yes, sir.
Hello? Yeah, is this clear?
Yes, sir.
Okay. So let others also speak, please. Don't hesitate to ask any questions. Okay? Then I will go with the non-sway analysis. First, we'll consider non-sway analysis. That means where there is no lateral moment of the frame. Okay. So first problem, let me take, analyze the portal frame shown in figure by the slope deflection method and sketch the bending moment diagram. Okay, this is the problem he has given you. This is the portal frame A, B, C, D. The columns are of same height, that is 3 meter. Beam is 6 meter long. Then the beam carries a UDL of say W kilonewton per meter. That is in this problem it is 10 kilonewton per meter is given. Okay. Now, if you analyze this frame, see now this is symmetric frame because loading is symmetric. Even end conditions, that means support A and support D are same. Suppose if one hinged, one fixed, then it is also non-symmetric, right? But both supports are fixed, loading on the beam is complete, so hence we call this as a symmetric. Okay. Next, now if you think of the rotations, you know that ends A and D are fixed, so therefore rotations at those ends will be 0. Means theta A and theta D are 0. Then what are the unknowns here? Yes, anybody? What are the unknown joint rotations?
Theta B and theta C.
Yes, theta B and theta C. Sorry, this should be C. Theta B and theta C are the unknowns. Okay? Okay. Let me proceed with the problem. So calculation of fixed end moments. Right? So now if you take the column AB, you know that column AB, it is not carrying any load. Hence the fixed end moments for the member AB at both ends will be 0. Then only beam carries here load. So for span BC, BC is nothing but a beam. So load is 10 kilonewton per meter and span is 6 meter. So you know that it is symmetric loading, hence MF BC will be minus WL square by 12. So W is 10 kilonewton meter, span is 6 meter. So if you simplify this, you are going to get here minus 30 kilonewton meter. Naturally, MFCB will be how much?
Plus 30 kilonewton.
Plus 30 kilonewton. Symmetric means either ends will be having same, but with the opposite sign. If left hand is minus, right hand should be plus. Now similarly, for span CD, that is again a column. That column also not carrying any loading. Hence, the fixed moments for MFCD and MFBC also 0. This is the same step what you have continued, means what you have done in even in continuous bits. Okay. Next, slope deflection equations. So here I first write the unknowns rotations and which rotations are known rotations. Here known rotations are what? Which are the known rotations here?
Theta A and theta D.
Yes, you know it. They are 0. That is why some value is there that is known. These theta A and theta D are called as known rotations. Of course, their value is 0. Whereas theta B and theta C are unknowns. Okay. Now, for span AB, what is the slope deflection equation now? MAB equal to 2EI by L into bracket 2 theta A plus theta B minus 3 delta by L plus MFEB. Let me substitute the values of theta A, theta B, delta and MFEB. Here you know that theta A is 0, delta is 0, MFEB is 0. Right? Only unknown is theta B. And span of the length, the height of the column, that is L means length of the column or height of the column, that is 3. So if you simplify this, you're going to get here 0.667 EI theta B. Right? Now, if you write for the other end, MBA, it will be 2 EI by L into bracket 2 theta B plus theta A minus 3 delta by L plus MFB. Again, theta A, delta, MFB are 0. So if you simplify this by putting those values, you will get here MB equals to 1.333 EI theta B. I think it is clear.
Yes, sir.
Okay. Now we'll go with the span BC. Right? For span BC, now MBC equals to 2 EI by L into bracket 2 theta B plus theta C minus 3 delta by L plus MFBC. Okay. Now here both the knowns are there, theta B and theta C, but delta is 0 and MFBC is minus 30. Okay. Now if you simplify this, see now I make use of the symmetry here. I don't write all the slope deflection equations like MAB, MBA, MBC, MCB, MCD, MDC. I don't write. I write only 50% of the equations. 50% means if you put the center line at the frame, you will get left side MAB, MBA, MBC. I don't write now MCB, MCD, and MDC. That is the advantage of symmetry. I tell you further. Due to symmetry now, theta C is minus theta B. Look at this figure. I have already explained this figure. If this is BC is a member, you know the tangent at B will be, that is rotation will be clockwise. Hence, the clockwise rotation theta B is positive. Whereas at C, tangent comes like this and this is anti-clockwise rotation. So theta C is minus. But because of symmetry, if loading is unsymmetric, then theta B and theta C will be different. But the loading is symmetric, so theta B and theta C will be same, but having different sign. Now, theta C is minus of theta B. Is it correct or not? So we can use this condition here. Is this clear? Theta C and theta B will be same because of symmetry, but only there is a change in sign. Theta B is clockwise, whereas theta C is anti-clockwise. So theta C is minus of theta B. Is this clear? Hello?
Yes, sir.
This property of symmetry you have to make use so that you can solve only 50% problem. Another 50% problem you can directly predict the values. I just tell you how to do that. Now, if I use this value of theta C as minus theta B, wherever theta C is there, I will put the value of theta C as minus theta B. Then you will get only one as unknown. Okay. Now, therefore, MBC will become 2 EI by L, that is 6, 2 theta B as it is, Now, the value of theta c, I will substitute it as minus theta b. And of course, delta is 0 and MFBC is as usual minus 30. So if you simplify this 2 theta b minus theta b means it is theta b, and 2 by 6 means you will get here 0.333 EI theta b minus 30. Right? I think it is clear.
Yes, sir.
Okay. Once if you make use of this symmetry, now you have got only one unknown. Even in MBC also one unknown, though there was theta c, but I have converted theta c in terms of theta b. MBA is also having theta b as the unknown. MBC is also now theta b as the unknown. Now let us solve for theta b for using the joint equilibrium condition. Now for joint B, what is the joint equilibrium condition now? It is MBA plus MBC equals to 0. Substitute the value of MBA and MBC which you are written in the second step. What is MBA? You written 1.333 EI theta B. MBC is 0.333 EI theta B minus 30. So if you simplify this 1.33 plus 0.33 means it is 1.667 EI theta B minus 30 equals 0. Therefore, EI theta B you are going to get here 18. So now you know that already you have used the symmetry. What is theta C? You have said it is minus theta B. Therefore, what is EI theta C then?
Minus 18.
Minus 18. Very good. You know that due to symmetry, it is theta C equals to minus theta B. By writing this MBA into MBC, we have calculated the value of EI theta B. So now, hence, you will get here EI theta C as minus. Okay. Only thing what you have made use is actually BC contains theta B, theta C unknowns. But I have reduced that theta, means I have converted theta, means I have put value of theta B in terms of the value of theta C in terms of theta B. So that I reduce the unknown as 1. Thereby, you can use only one condition of joint equilibrium and get one value. And because of symmetry, you will get the other value. I think this is clear. Is this clear?
Yes,
Hello?
sir.
Now we will go to the last step, final moments. Now you need to substitute the values of EI theta B and EI theta C in the equations. For example, first equation, MAB you are simplified as 0.667 EI theta B. What is EI theta B? 18. If you simplify that, you are going to get here plus 12 kilonewton meter. Next, MBA. The equation is 1.333 EI theta B. If you simplify that by putting the value of EI theta, you will get 24 kilonewton meter. Next, MBC. It is 0.333 EI theta B minus 30. Again, putting EI theta B as 18, you will get minus 24 kilonewton meter. I calculate only these three. How you put other three values, I just show you here. I think this much is clear now. Okay, I assume that you have understood. Next, just I will put here a portal frame. So I write down these three values first. MAB, this end moment, plus 12 kilonewton meter. MBA, what is the value of MBA? That is also plus 24 kilonewton meter. MBC, minus 24. Now I write these three values right now separately. Right? How to write that? See, MAB. Right? What is the corresponding member on the other side? If you put the center line here, it is symmetric. So if you put here center line, so now AB, what is the corresponding member on the other side? DC. Isn't it? AB, DC. So if this is AB is 12, this should be minus 12. Hope you are understanding. Next, BA, what is the corresponding member on the other side? CD. If BA is plus, CD will be minus. Similarly, if BC is minus, CB will be plus. Are you getting idea? Shall I repeat it? I will repeat it again. We have got three values here, MAB, MBA and MBC. Okay. Now I write other three end moments making use of these by changing the sign. MAB, right, 12 kN. Now it is MDC is minus of MAB. What is MDC? Minus of MAB. Minus of MAB means minus 12. Next, BA is 24 kilonewton meter. The corresponding member on the other half is CD. So MCD is minus of MBA. So it will become minus 24. Next, for beam, MCB is minus of MBC. MCB is minus of MBC. Minus into minus, it will become plus. So this is 24 kilonewton meter. Hello? Hello?
Yes, sir.
Do you understand now how to write the first 50% problem you have to solve? Other 50% values, just by changing the end condition for the corresponding member, you need to write. I hope you understood.
Yes, sir.
I want some more answers from some more members. I think repeatedly I am getting same from same members. Fine, it is very good. They are
Yes, sir.
interacting. I am very happy about that. But others also, you should say whether you have understood or not. Yes, any more? Hello?
Yes, sir.
Keep on your mic whenever I ask and say yes or no at least. Hello? Shall I proceed then?
Yes, sir.
Shall I proceed?
Yes, sir. Yes, sir.
Okay. Now, after writing these three, I told you how to write these. Then I will write now MCB. What is that now? It will be minus MBC. MBC is minus 24. Minus into minus, it will become plus 20. MCD is minus MBA. So it will become MBA is plus 24. So it will become minus 24. Then MDC equals to minus MAB. So MAB is plus 12. So it will become minus 12 kilonewton meter. This is how you have to make use of the advantage of symmetry. Whenever the portal frames are symmetric, with the end conditions and loading, don't try to solve all the, don't write all 6 equations and 2 equilibrium, joint equilibrium conditions, solving them, that you can avoid. Only you have to solve 50% of the problem and use only joint one condition, so that you will get all the answers. Okay. Now we'll see here the markings. MAB is plus 12, so means it is clockwise. MBA is also plus 24, again it is clockwise. MBC is minus 24, anti-clockwise. MCB is plus clockwise. MCB anti-clockwise, minus. And MDC is also minus 12, this is also anti-clockwise. Okay. Now, if you turn like this push that column, bottom end of the column towards what side? If you turn the arrow like this, it push the bottom end of the column towards right or left? Towards right or left?
Right.
Right. Okay, I have shown here. This is the column, I have shown here 12. Now you come to the top end of the column AB. If you turn the arrow like this, whether it push the top end towards left or right?
Left.
Towards left. Left.
Very good. So I have marked here this 24 kilonewton meter left. Then join that 0 to 12, then this to this. Okay, then it goes here. Okay, this is one column. Next, come for beam. You can separate out beam column and you can combine them also. There is also nothing wrong in that. Okay, now if you take the column, this is anti-clockwise movement. Now, when I say the vertical member, I will ask whether it push towards left or right. But when it is a horizontal member, that arrow lifts up or push down. What it does now? MBA
Lifts up.
lifts up.
Lifts
Fine.
up.
24 is up. Similarly, CB,
So
what it
lifts
does?
up, sir.
Lifts up.
It
That is
also
also
lifts.
20. Okay. Then this ordinate is 24. This ordinate is 24. Join it. You will get a rectangle. Suppose if loading is unsymmetric, these two values will be not same. This may be 30. This may be 24. Then you will get a trapezium shape of the end moment diagram. Now it is a symmetric loading. Hence it will become a rectangle. Same case with the column. Now this is anti-clockwise. What it does? What it does?
Moves towards right.
Yes, it moves the top end of the CD column towards right. Therefore, 24 towards right. What this does? This is anti-clockwise, minus
Moves towards left.
left. So it is moving towards left. So you can draw this. See now, if you draw the center line here, left side and right side will get mirror image. Left side and right side will get a mirror image. Are you understanding mirror image? If you see in mirror, exactly it get reversed. Are you getting this idea?
Yes, sir.
Okay. Now you have to superimpose by free bending moment ordinate. Here only loading on the span BC. There is no load on the AB, so there will be no free bending moment diagram on AB. Similarly on CD. Only BC is carrying UDL. What is our free bending moment diagram now? Free bending moment value WL square by how much?
8.
8. If you simplify that by this WL square by 8, you will get here 45 kilonewton meter. See, this is from here to here, right? But net bending moment diagram, see, this is why in the beginning of portal frame, what I said, the main object of the design of portal frame is to reduce the moment in the beam. See, if you design the beam as a simply supported beam, you need to design for a 45 kilonewton meter. But now how much moment is going to be reduced? Look at this. See, this is plus moment, this is minus moment. In 45 minus this value, how much is this value? Which I have shown with this brown arrow, 24 kilonewton meter. 45 minus 24, how much is left now? 21 kilonewton meter. Means if you design it as a simply supported beam, you are designing for 45 kilonewton meter. But when you take it as a column beam structure, that moment is going to be reduced to 21. So there is a huge difference in the bending moment. Naturally, see, design means in beam design, what you design the beam is. In the design of beam is what? You have to fix the dimensions and you have to find what is the steel and what is the grade of the concrete. If the bending moment is less, you are going to get the less depth of the beam. If the bending moment is more, you will get more depth and as well as more steel. So it will become bending moment is more means more depth of the beam, more steel. If the bending moment is reduced or less, depth of the beam is less as well as steel will be less. That advantage you are going to get by this that rigid connection between the column and the beam. Are you understanding now? So how much moment is going to reduce, that you have to need to understand here. This is the advantage of a fixed beam also. Yes, is this clear? Hello?
Yes, sir.
I think it is clear. If you design it as a free, simply supported beam, you need to design for 45 kilonewton meter moment. But if you take this as a fixed beam or rigid joint, automatically you need to design only for 21 kilonewton meter, because this 45 is plus, this is minus. So automatically you will be getting only plus 21 kilonewton meter, which is much lesser than the bending moment of a simply supported beam. Okay, is this clear?
Yes, sir.
Okay. Now this is first problem on non-sway analysis having the symmetric problem. So next I will go with the sway analysis. See, all of you listen carefully. This theory, if you understand properly, applying the theory to problem is not a difficult. You are writing only one additional equation, which is called as a shear equation. The rest of the two equations, joint equilibrium equations, are similar to what you have done earlier. Listen me carefully now. So it is a very important theoretical aspect. You need to understand the theory. Then automatically problems you can solve very easily. Okay. Now first let me see what are the causes of sway. So first three portal frames when I shown you, they were symmetric with respect to end conditions and with respect to loading. So there was no sway at all. Now then what is the reason for sway? Look at this. First condition, eccentric or unsymmetrical loading. What is that? Eccentric or unsymmetrical loading. Means if you take a point load, if the point load is not at the center, if the load is not at the center, then lateral moment of the frame takes place. Okay, this is the first condition. Second reason or cause for same is unsymmetrical outline of portal frame. What do you mean by unsymmetrical outline? This is means see this here outline is same. This height of the column AB, height of the column CD are same, but here they are different. Outline is not same. Here this outline means this, they are symmetric, but here it is outline is not symmetric. Means heights of the columns are different here. What is the reason here? Heights of the columns are different. That is why again lateral moment takes place. Third, different end conditions. What does that mean? See here. Suppose if both ends are fixed, if the load is at center, then it is symmetric. Here, suppose no loading is there, but one end A is fixed and say D is hinged. In this case also, the lateral moment of the frame takes place. Is it clear here? This is due to unsymmetrical loading. This is the unsymmetrical outline. This is what is this? Unsymmetrical end conditions, we can say. Different end conditions is nothing but unsymmetrical end conditions. If this is fixed and this is fixed, symmetrical end conditions. If one is fixed and another is hinged or roller, this is different end conditions or unsymmetrical end conditions. Then also the lateral moment takes place. Next reason, non-uniform section of the members of the frame. For example, here end conditions are same. Because of that, there is no sway here. But this column has got I and this column has got 2I. The moment of inertia value for both the columns are different. Means here, this column size and this column size will be different. Say for example, if you take a size of column as a 230 by 300. So here this column size will be say 300 by 400. The top dimensions, if you look at the cross section of the column, the dimensions of this column and this column will be different. How do you calculate usually I? You know that BD cube by 12 for rectangular section. Am I right? Now if the B and D in the cross section, if they are different for columns, then again the frame get swayed. Means there will be a lateral moment in the swing. Lateral moment in the frame. Next, horizontal loading on the columns of the frame. This is this way. So because of the horizontal loading, again here end conditions are same. Vertical loading may be symmetric, but with vertical loading symmetric, only one horizontal load is there. Then also the frame get swayed or lateral moment of the frame takes place. Maybe load at the joint or it may be on the member. Next reason is settlement of the supports of the frame. Means this is way. If here, so far what you have used horizontal moment. Now here this is a vertical moment. Suddenly, suppose if you are standing on assume that one platform or two different stones. Suppose one stone suddenly gets broken, then what happens? I think you get that leg down. That is also this is here vertical translation is taking place in this kind of settlement. So last reason is a combination of above. What is a combination of above? Means 2-3 reasons may be there. Means supports may be different conditions. I may be different, lateral loading may be different, unsymmetrical vertical loading may be there. There may be out of 6, 2, 3 combinations may be there. That is called a combination of above cases. So is this clear? Hello?
Yes, sir.
Yes, sir.
See, first you have to identify whether sway is there in the frame or not. To understand whether sway is there or not, you need to remember, or you have to understand these 6 reasons for the sway. Okay? Okay, whenever problem comes, I tell you what are the reasons of sway further, but you need to understand these. Next. Now, let us take one portal frame. Here, can anybody tell me what are the reasons of sway here? First, what are the reasons
Horizontal
of
loading.
horizontal loading? Very good. Yes. One more.
Settlement.
No settlement.
Different heights.
Yes, different heights of the column. Third reason.
Unsymmetrical loading.
Yes,
Loading.
unsymmetrical
Vertical
vertical
loading.
loading. P is not at center. Let us assume that is not at center. So there are 3. That is a combination what I said. There are 3 reasons here. One is horizontal loading. It may be towards left or right. That is one reason. Another is unsymmetrical height or different heights of the column. Third is unsymmetrical vertical load on the B. Okay. That means, is there sway is there in the frame or not? Yes. Okay. Then how many unknowns will be here?
3.
3. Because theta A 0, theta D 0, theta B and theta C as joint rotations. Along with that, now there is a lateral movement of amount, say delta. Delta is the sway. Right? Delta is what it is called as the amount of sway. Okay. Now, to calculate theta B and theta C, assume that there is no delta. What are your joint equilibrium conditions? Assume that there is no delta right now. To find out theta B and theta C, what are your joint equilibrium conditions?
MBC plus MBA equal to 0.
Fine.
MCB plus MCD equal to 0.
Very good. For joint B, it is MBA plus MBC equals 0. Next, for joint C, it is MCB plus MCD equals to 0. These 2 equations you already used. Now, we need one more additional equilibrium equation to find out the value of sway. That is delta. That's what I have called it as a shear equation. What is the shear equation then? Let me see this. That is nothing but sigma fx equals to 0. This sigma fx equals 0 you have to write for the whole frame. Okay. Look at this now. This frame I have taken once again. Okay. So now to write shear equation, as there is a horizontal loading, you need to write their horizontal reactions. Right? So let us assume there is a HA is a horizontal reaction at A. HD is the horizontal reaction at B. Right? Because you want to write a sigma fx equals 0 for the whole frame. So you need to write the action is there. Action means the already given loading. Plus you need to find reactions in the x direction. X direction is what? It is a horizontal direction. So let HA be the horizontal reaction at A and HD be the horizontal reaction at D. Is it clear? Now can you tell me what is sigma fx equals 0 for the whole frame? Anybody, can you try? This you have to take the algebraic sum of the horizontal forces and equate it to 0. Can anybody try?
HA
W
plus
plus
HA.
W plus
One of you.
W plus HA plus HD minus of WH2 equal
Very
to
good.
0.
Very good. Here there are 4 horizontal forces. One is W towards right, HA towards right, HD towards right, whereas this W kilonewton meter is acting towards the left. P is not going to come here because P is a vertical loading. See, first, if you take the sign conventions, right moving force as positive, you take left moving force as a negative. There are three right moving forces, which are those HA, HD, and W. And left moving force is this UDL. Then what it will become now? HA plus HD plus this W. This is UDL. What is the total UDL now? It is acting for a span of height H2. So minus W into H2 will give you the total UDL, which is acting in the leftward direction. Hence it is minus, this is equals to 0. So are you getting the idea here? This is the only additional equation you need to write for solving the sway problems. These two equations you already written, hope you know it very well. And this equation you need to write. This is very simple. Only you are taking the algebraic sum of the horizontal forces acting on the frame and equating it to 0. Yes, any doubt over here? Yes?
Sir.
No. So I will put a question here. Suppose there is no UDL here, then what will be your shear equation? Assume that UDL is not there.
HA plus HD plus W is equals to 0.
Very good. HA plus HD plus W equals to 0. Assume that W is not there. Only W is not there.
HA plus HD minus W H2.
H2 equal to 0.
HA plus HD minus W into HD equals to 0. Okay. Assume that there is no W as well as this W kilonewton meter UDL. Both loads are not there. Assume it.
HA plus HD equal
HA plus HD equals to 0. You may get these three cases. Right? You may get only one load on the vertical member. You may get two loads on the vertical member. You may not get horizontal load on the members. These are the possible three cases you may get in your problems. Are you understanding what I am saying? Right? You may have only W. You may have only UDL. You may not have both the loads at all, like that. These are the three possible cases. For those three possible cases, how this sigma fx equals 0 changes, you should understand. Don't try to remember this as a final equation. HA plus HD plus W minus W into HD equals 0 is not a standard equation. It depends upon the type of loads acting on the structure. Even instead of UDL, you may have point load this side. Are you understanding my point? Yes?
Yes, sir.
Okay. Then shall I proceed? Now important step is how to calculate HA and HD. If you know how to calculate HA and HD, then problems become simple. I will just tell you theory to calculate HA and HD, then I will stop it. Problem we will take it in the next class. Okay. Now how to calculate HA and HD? Listen here, I have taken the free body diagram of AB column and DC column, CD column separate. Okay. So first you take a column AB, you know that load is acting W at a distance A from end B. Height of the column is H1. Okay. Now let us assume these end moments, MAB and MA. Let us assume both clockwise. I will assume that. Because this calculation of HA and HD will be after writing the slope deflection equations. You are writing the MAB and MBA also, you are writing in the step number 2. Right? Assume that MAB is also clockwise. MBA is also clockwise. Let me assume it. So HA I assume towards right. Okay. Usually how this HA means, it will oppose the moment caused by the loads. See now, MAB and MBA are clockwise. Right? This HA should oppose that moment. If you take the moment of HA about B, what is the sign? If you take the moment of HA about B, what will be its sign? What is the nature of moment, you can say?
Anti-clockwise.
Anti-clockwise. Turn this HA tip towards B, it will become anti-clockwise. Thus, it will get balanced. Right? Now, similarly, if I take the column CD, first you take the height, it's loading on that, assume reaction. Then again, both end moments, I am assuming clockwise. I am assuming DC as well as CD clockwise. Some books they have taken these as anti-clockwise. If they take this anti-clockwise, HA will become left, right? Because the moment, end moments and this moment due to horizontal, that reaction should balance. Otherwise also you write it, then you will get minus sign, that is fine, no problem. So is this clear now? I am assuming here end moments at both the ends clockwise for both the columns. Okay, this figure is clear. Loading, and additional thing is you have to mark the end moments. Now, to get the value of HA, what you need to do is you have to take the sigma MB equals to 0. Suppose if I take moment about A, you will not get HA. Moment due to HA will be 0. Here object is to get the value of HA. Then if you take moment about B, how many forces are acting on this column now? How many forces are acting on this column? Can anybody tell me?
2.
3, sir.
Still think. 4.
4.
See, load is a W, and even forces, moments are also generally called them as force.
Yes.
Right? 2 end moments, 1 load and 1 reaction. W, HA, MAB, MBA. These are the 4 forces acting on the column AB. Now, if you take moment about B and a summation of that equals to 0, what will be your equation? So first you take clockwise moments. MAB is clockwise plus. MBA is clockwise plus. Then what is the moment due to W about B? What is the moment about of W about B? Yes.
W into
W into A, sir.
Clockwise. Very good. So it is minus. What is the magnitude of the moment? Here I have shown. What is the magnitude of the moment?
W
Hello?
into A, sir.
W into A. Very good. Next you take moment due to HA. HA into, what is the height of the column? H1. Isn't it? This is the moment. HA into H1. What is the sign? Minus. Why? The moment due to HA about B is also,
Anti-clockwise.
yes, it is also anti-clockwise. So this equals to 0. Is the step is clear? Clockwise moments minus anti-clockwise moment. MAB and MBA assumed clockwise, both are plus. The moment due to W and HA will be anti-clockwise, both are taken minus and equated to 0. Therefore, HA is equals to MAB plus MBA minus W into A divided by H1. Is it clear? Hello?
Yes, sir.
Okay. Now similarly you have to calculate HD. To calculate HD now what you need to do now? To calculate HD, this is for
Moment
the-
at C.
Taking moment about C.
yes, you have to write sigma MC equals to 0. Fine. Can you tell me the equation now? Can you tell me the equation?
HD into H2
Sign. You have to tell with always sign.
minus HD into H2
Yes, correct.
plus WH2 into H2 by 2
Very good.
plus MDC plus MCD equal to 0.
Very good. Again here 4 forces. 2 moments, 1 UDL and 1 point. Very good. Very good. Look at this. Clockwise moments. MCD and MDC are assumed clockwise plus. This W is towards left. So if you turn towards left and turn towards C, that will cause clockwise. So it is plus W into H2 by 2. That is nothing but W into H2 square by 2. Then the moment due to HT will be anti-clockwise. So minus HD into HD equals to 0. Therefore, HD equals to what it will be? MCD plus MDC plus W into H2 square by 2 divided by H2. This is how you need to calculate the horizontal reactions. Is this clear? Hello.
Yes, sir.
It's clear now? This is a very important thing. Just you have to mark the first column, mark the loads, assume the reaction, assume the end moments. Then you need to write for the HA and HD. Next class, I will take the problem. This much you read it again. I think it is there in the notes also. I think I have to send mostly. I will send it today, notes of these classes. If you understand this problem, solving problem is not that difficult, because already 75% of the problem remains same. Only this shear equation sigma fx equals to 0 you have to write. For that you need to calculate the horizontal reactions for the columns at the bottom ends. If you know this HA and HD, here again basic things, how to take moments. You have to write the equilibrium conditions, and from those only you are writing the equations of equilibrium only and getting the values of HA and A. Then once if you get the value of HA and HD, you have to write the sigma fx equals 0 for the whole frame. Then you need to solve 3 equations for 3 unknowns.